Hi, today we're looking at Pearson Edexcel Functional Skills Maths Past Paper 5, Level 1, and we're going to be starting with the non-calculator section. As usual, you can find a link to this paper underneath the description. Question 1. Here are four numbers. We've got 1.878, 1.76, 1.7 and 1.703. Write these numbers in order of size. Start with the smallest number. Right, so the way I like to do these is to actually write them out one above the other. So we've got 1.878, 1.76, so I'm using the decimal point to line them all up. 1.7 and 1.703. Then to help to be able to compare them, because we've got the decimal point here, we can just put zeros in here to sort of fill in the gaps. And now because these are all ones, 1 point, actually we can just compare these numbers here. So we're looking for the smallest. Well, the smallest is going to be 700, then 703, then 760, and finally 878. So if we're going to be ordering them, we'll start with it was given to us as just 1.7. Then the next one we had was 1.703. Then we've got this, which was actually given as 1.76. And finally, we had this with all three decimal places given, 1.878. Right, for the next part. Here are four fractions. 1/2, 2/5, 3/10, and 3/4. Write these fractions in order of size. Start with the smallest fraction. Okay, well what I'm going to do with these actually is I'm going to look at them and say, well, I've got half here. Okay, so I'll put half. Now, which of these is smaller than half and which are bigger than a half? Well, 2/5, the 2 is less than half of 5, so this is less than a half and this is less than a half. 3/4, well, I know that's more than a half, so I can write that over this side. Okay, so actually all I'm trying to work out is which is smaller, 2/5 or 3/10. Okay, so if we put these 2/5, 3/10. Well, if we want to compare them, really we want to have the denominators the same. At the moment they're different, so that won't work. But this denominator, the 5, goes into 10. So we can rewrite this fraction as being over 10. So we can say, well, to go from 5 to 10, really, we've doubled it. So if we're doubling the denominator, to keep the fraction the same, we need to double the numerator as well. So 2 times 2 is 4. And now we can see 4/10 is clearly bigger than 3/10. Okay, so we can write 3/10 as our smallest fraction down here. And then 4/10, well actually the 4/10 originally was 2/5. So we've got the four fractions written in order from smallest to largest. Question 2. Work out 10 squared minus 2. Okay, well, 10 squared, that means 10 multiplied by itself. Okay, so if we multiply by 10, we just add a 0 on the end. So that means that this is actually 100 minus 2. So 0 take away 2, we can't do it. So we need to take one from this 0, but we've got nothing to give. So in fact, we're going to have to reduce this 1 to a 0 and pass 1 across. Now we can do the same again. So we reduce this 10 down to 9 and pass 1 across. So now we're actually saying 10 take away 2, which is 8. 9 take away nothing is 9. And nothing take away nothing, it's just nothing. So we've got 98. Or we could have just said, well, we've got, let's put this here, we've got 100 minus 2. We could just count back from 100. So 99, 98. Now for part B, work out the range of these numbers. Well, the range is the biggest minus the smallest. Now these are negative numbers, so we've got to be careful with this. Now the biggest number is going to be, because they're all negative, it's going to be the least negative. So the biggest is actually the minus 3. And the smallest number is going to be the most negative, which is the minus 13. So if we write this down, we're going to have minus 3 minus, because we've got to take away. Now the smallest number is actually minus 13. So we've got two minuses here. Now hopefully you'll remember that when you've got two minuses together, those minuses actually cancel, or if you think of it as two minuses and you put one on top of the other, makes a plus. So minus 3 plus 13. Okay, so what we're saying is we've got, move this up here. If we think of a number line, so we've got 0 here, minus 3 down here, and we need to add 13 onto this. Well, it's going to take us 1, 2, 3 just to get up to 0. So if we've used up 3 from the 13, that means we're going to be left with another 10. So our answer is just going to be 10. Okay. Different ways of doing it. What you could do instead is just start with the minus 13 and count up until you get to the minus 3. Or because they're both negative, you could say, well, actually, I can ignore the negatives and just say, what's the difference between 13 and 3? And you'll still get to 10. Question 3. Vlad needs to put fencing along each side of his garden. His garden is in the shape of a regular octagon. Each side of the octagon is 2 meters in length. There will be a 1 meter gap in the fencing for a gate. Fencing costs £22.50p per metre. Work out the cost of fencing the perimeter of the garden. Right, so we've got quite a lot going on. Now, I haven't asked you to draw this, but it might help if you can draw a picture of the garden so we can sort of visualise it a bit. Now, if it's an octagon, we can think of it as, well, it's going to have a top, a bottom, 2 side bits, and then it's like we're joining these side bits up like this. Yeah, it doesn't need to be precise, it's just to give us an idea. And they're saying each side of the octagon is 2 meters. So that's 2 meters, that's 2 meters, that one, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, but there will be a 1 meter gap in the fencing for a gate. So, okay, maybe we can have this as our gap. So if our gap is 1 meter, that means the rest of this is going to be 1 meter. Okay, so let's ignore this 2 meters for now. We've got it split up. Okay, now fencing costs £22.50 per meter. So we want to know how much fencing have we got all the way around. So we've got our gap here. So maybe if we start from here, we've got 2, 4, 6, 8, 10, 12, 14, and 15, because we're not going to be using the gap. So we've got 15 meters. That's the perimeter. And we've got £22.50 per meter. Right, so what we want really is 15 lots of £22.50. Okay, so we could do this using the column method. But actually, I'm going to do this differently, and I'm going to think of 15 as, well, that's 10 plus 5. Okay, so I know how to multiply by 10. So I'm going to say, well, first of all, let's do 10 times £22.50. Now, if we're multiplying by 10, we're making it bigger. And because we've got 1 0, we're going to just be moving the decimal point across one. So we're actually going to be 225.0. It's going to be money, so we put the pound sign, and we need to put an extra 0 to make it pounds and pence. So 10 metres would be £225. Now, we've done the 10, we need 5. So again, we could do this using the column method, or actually we can say, well, if 10 of these is 225, 5 is half of 10. So really what we want is 225 divided by 2. So 2 goes into 2 once, 2 goes into another 2 once, 2 goes into 5, 2, 4, 6 would be too much, so it just goes in twice with 1 left over. So we can put a 0.0 so we can carry our 1 over. We need to put our decimal point up here. How many times does 2 go into 10? 2, 4, 6, 8, 10. That's 5 times. So 5 lots of £22.50 are 112.5 or 50. Now to get our 15 times, we just add these together. So 0, let's put a plus in there. 0 plus 0 is 0. 0 plus 5 is 5. Bring down the decimal point. 5 plus 2 is 7. 2 plus 1 is 3. 2 plus 1 is another 3. And that's our total price. Okay. So as I say, you could do it differently. You could work this out with one big multiplication, but I quite like splitting it up into 10 and then 5. So, question 4. Kenny is going to borrow £9,000 to help buy an electric car. He pays back the £9,000 at 5% simple interest over 4 years. So simple interest means that the interest amount is the same each year. Kenny thinks he will pay back a total amount of £11,800. Is Kenny correct? You must show your working. So, what we need to do to start off with is work out what 5% of £9,000 is. So you could do 5 divided by 100 times 9,000, but we're not going to do that way because this is a non-calculator section. So we're going to say, well, what's 10% of 9,000? Well, 10%, we just take a 0 off, so it's going to be 900. And similarly to what we did in the previous question, if we want 5%, 5 is half of 10, so we want half of 900, or 900 divided by 2. So we're going to say 2 goes into 9, 2, 4, 6, 8. That's 4 times, 1 carried over. 2 goes into 10, 2, 4, 6, 8, 10. That's 5 times. And 2 into 0 goes 0 times. Okay, so that means that 5% of 9,000 is £450. Now it's over 4 years. So that means we want to multiply our 450 by 4. Well, 4 times 0 is 0. 4 times 5, 5, 10, 15, 20. So 0, carry the 2. And 4 times 4, 4, 8, 12, 16. Add on the 2, 17, 18. Put our comma in there. So we've got a total of £1,800. That's the interest. Now it says Kenny thinks he will pay back a total amount of 11,800. Well, he's not just paying back the interest, he's also got to pay back the £9,000. So the total he'll pay back will be 9,000 plus 1,800. So 0 plus 0 is 0. Same again. 0 plus 8 is 8. And 9 plus 1 is 10. So you've got a total of £10,800. Well, that is not equal to £11,800. So is Kenny correct? No. He is incorrect. And that's the end of the non-calculator section. Okay, so now we're going to look at the calculator section. Question 1. Wayne earns £13.55p for every hour he works. These are the hours per day he worked last week. So on Wednesday he worked 5 hours, Thursday 7.5 hours, Friday 6 hours and 30 minutes. How much did Wayne earn last week? Well, we could work out how much he earned on each day separately and then add them together. But I think it's going to be nicer if we add the hours together first and then multiply it by the hourly rate. So Wednesday, we've got 5 hours, so that's fine. We've got 5. Thursday, 7.5 hours. I'm going to turn that into a decimal to make it easier when I put it in my calculator. And Friday, 6 hours, 30 minutes. Well, 30 minutes is half an hour. So we can write that as 6.5 or 6.5. So 5 plus 7.5 plus 6.5 gives us 19 hours. So he worked 19 hours, and for each hour he got paid £13.55. Which gives us a total for the week of £257.45p. Question 2. Here is a set of 8 numbers. So 184, 150, 172, 168, 150, 179, 175 and 182. Work out the mean value of this set of numbers. Well, the mean is the total divided by the frequency, or how many. So with the total, we'll go straight to our calculator and we'll do 184 plus 150 plus 172 plus 168 plus 150 plus 179 plus 175 plus 182. Now, instead of going straight to the answer, I'm going to write down the total I've got first. Because you could go straight into dividing by the frequency, but then if you've made a mistake somewhere in the final bit, you wouldn't get any workings marks. So we want to kind of do an interim step. So how many numbers? Well, they've told us there's 8 numbers. Okay, so now we've got that, we can do divide by 8, and we get 170. Okay, which we can put down here. Use a reverse calculation to show a check for your answer. Right, reverse calculation, so that means we start with the answer, 170. And how did we get that? Well, we divided by the 8. So the opposite of dividing by 8 is going to be multiplied by 8. So we've still got the 170 there in the calculator. Multiplied by the 8. takes us back to 1,360, which is what we were expecting. Okay, so question 3. Jamie has this diagram of his kitchen floor. He is going to cover the floor with tiles. The tiles are sold in packs. One pack of tiles will cover 1.2 meters squared. Tiles can be cut and joined. So we've got the floor here, 10 meters this way, 6 meters along, sort of L shape. Work out the number of packs Jamie needs to buy. You must show you're working. Right, well, if we know one pack of tiles covers 1.2 meters squared, we need to work out what's the total area. And then we can use that to work out how many packs. So we've got this funny shape. We want to work out the area. Well, I don't know how to work out the area of a L shape in one go. So instead I'm going to work out the area of some rectangles. So I'm going to split this shape up. You could work out one big rectangle and take away this space, but I think I'm going to draw a line down here and split this into 2 rectangles, a long one and one over here. So the area of this rectangle, well, the area of a rectangle is the length times the width. So it's going to be the 10 times 2, and I don't need my calculator for this one. It's going to be 20 meters squared. Now for this rectangle, well, we've got, this is 3 meters. We haven't got this measurement here because the 6 goes all the way across. Now we have got that this little section is 2 meters. So that means that this bit over here, could have used my ruler for that, make it a bit tidier. Still not very tidy, but hopefully you can see what I'm doing. This is going to be the difference. So if the full length is 6 meters, we take off 2 meters, which is going to leave us with 4 meters here. So 3 times 4, it's going to be 12 meters squared. So the total area will be 20 plus 12. So 20 for this rectangle, 12 for this rectangle. And we can use our calculator. Always good to check. So we've got 32 meters squared. Now, how many packs are we going to use? Well, if one pack covers 1.2 meters, well, we want to know how many 1.2 meters fits inside 32 meters. Or in other words, 32 divided by 1.2. Which gives us 26.66 recurring. Now, if you go in a shop and try to buy 26.6666 packs, they won't be able to help you. They'll say, no, we can either sell you 26 packs or 27 packs. Or 26 won't be enough. We need more. So we're going to need 27 packs. Question 4. Jarita has 103 lamps in her shop to sell. The price of each lamp is £26.99. Jarita wants to estimate her income from selling these lamps. Estimate the income for Jarita. You must show you're working. Right, well, if we're doing an estimate, we want to do sort of approximate sort of rounding. So we can say, well, 103, well, that's close to... Now, it's up to you normally if you round to the nearest 10 or 100. With this, 103, it's very close to 100. So I'm going to round there. And £26.99, well, again, we want to round it, so we're saying approximately equal to... You've got a choice. I'm going to round it to £27. Because I know I'm going to have to multiply it by 100, and multiplying by 100 is nice and easy. Equally, you could say, well, £26.99, I'm going to round it to the nearest £10. So you could round it up to £30. Okay, so this is where there can be more than one right answer. But I'm going to do 100 times 27. I can use my calculator, but I know if I've got 27 times 100, I'm going to put 2 zeros on the end. So I've got £2,700. Okay. Now we've got question 5. A bit wonky. Michael is organising a meeting at his rugby club. He wants to display the results of the games the rugby team played last year. Michael has this information. So they won 25 games, and on the pie chart they're saying that's an angle of 150 degrees. They lost 15 games, and they drew 20 games. Okay, Michael starts to display this information in a pie chart, which is here, and they're asking us to complete the pie chart for Michael. So what we're saying is this win, so this angle represents this. So this is 150 degrees. Oh, no, I've written 15 degrees, 150 degrees. Okay, right. Now we've got to work out these other two angles. Now what I'm going to do first of all is have a look and say, well, we could look at the total, but actually I'm going to say, well, we've gone from 25 games and we're representing that by 150. So what's our scaling factor? How much are we multiplying this by to get to 150? Or if we think the opposite way round, think, well, how many 25s fit into 150? So 150 divided by 25 gives us 6. Okay. So to get from the number of games to the angle size, they're multiplied by 6. So we can do the same for the losses and the same for the draws. So if we do 15 times 6, we get 90 degrees. And if we do 20 times 6, we get 120. Now we can do a check, because I know the total number of angles in a circle are 360. So if I add my 150 with my 90 and my 120, I do in fact get 360 degrees. So that's good. Right, so we've got to now show these on our pie chart. Okay, well, the losses, the 15 losses, have an angle of 90 degrees. Well, I'm actually going to use my protractor here. But to be honest, you don't have to use a protractor. You could actually let's do it with. Show you how you can do it with your ruler when it's 90 degrees, and then we'll check it with the protractor. So what I'm trying to do is, I know that a 90 degrees is a right angle. So if I can find something like the end of my ruler, or I'm using this straight line here. I'm lining that straight line there, get it near the centre, and draw that out. Okay, so I believe that what I've made here is a right angle, and I'm going to use my protractor to check. Yeah, that looks pretty good to me. And to show it's a right angle, we draw a little sort of square in the corner. So if this is 90 degrees, this must be whatever's left. 120 degrees, and again, let's check that. So we're starting on this side, 0, 10, 20, 30, all the way up. Actually, it's moved a little bit. Measure it all the way around, 120 degrees. Now we just need to label it. Well, the 90 degrees was for lose, 120 degrees was for draw. Question 6. Danielle is a fitness class instructor. She is updating her website. Danielle has this information about the ages of people attending fitness classes in the UK. So we've got age in years and number of people for every 1,000 people attending class. Okay, so we're saying there were, for every 1,000 people that attended, 100 of them were under 18, 310 of them were between 18 and 34, 370 of those were between 35 and 54, and 220 of the 1,000 people were 55 and over. Danielle wants to display this information as a graph. On the grid, show a suitable graph for Danielle. Right, well, we've got very distinct categories here, so I think I'm going to draw a bar graph. Okay, and I'm going to put my age along the bottom. So we're going to have age in years, and we've got 4 age categories, so I'm going to do each of these is going to be one of my categories. So this is going to be under 18, this will be 18 to 34, 35 to 54, and 55 and over. Now we've got to think about our scale going up this side. So what's the biggest value we've got? So we've got 370. Okay, it's the biggest of these values. So we think about how we want to put our numbers on this axis here. Well, we could say 100 for each big box, so 100, 200, 300, 400. But then we've got quite a bit of graph paper up here not used. So maybe instead we could say, what about if we do 2 boxes for every 100? So that'd be 100, 200, 300, 400. Yeah, and that's going to work. So let's write those on, because we want to go at least as high as the biggest value we've got, and 0 at the bottom. And this is number of people. And I'm just going to put 4. So we're just copying what they've got up there for every 1,000 people attending classes. Okay, so now we've got to start marking them on here. Well, the first one is fairly straightforward. We've got 100 people, so we can just do a line on 100. I'll try and make it a bit darker so we can see it there. Okay. Then the next value we've got is 310. Well, 300's up here. Now, because we've got 2 boxes for each 100, that means we've got 20 little boxes for a difference of 100. So we're saying that this difference is 100, but it's 20 boxes. So if we do 100 divided by 20, it means that each little box is worth 5. So if we want 310, we've got 300 to this line, 305, 310 is actually going to be here. Okay. Then the next value we've got is 370. So that's on this column. So again, if we think every 10 is 2 boxes, so 310, 320, 330, 40, 50, 60, 370 is going to be here. And for 55s and overs, we've got 220. Well, here's 200, 5, 10, 15, 20. So I've marked the tops of all my bars, and then I'm going to draw my lines in. So we can put a y-axis down there. Let's put our x-axis at the bottom. Now we can put these lines in. Okay, you don't have to have your bars touching. I make them touch because it's easier. And then we just need a title for this. So we can just say fitness class, ages, something like that. And there you have it. Yeah, now we've got a second part to this question. For every 1,000 people who attend fitness classes in the UK, 370 are aged 35 to 54. Daniel thinks that 370 out of 1,000 is less than 5%. Is Danielle correct? Show why you think this. Right, so we've got 370 out of 1,000. We want to turn this into a percent, so we're going to multiply it by 100. So 370 divided by 1,000 times it by 100, and we've got 37. Oh, what am I doing? Try that again. 370 divided by 1,000. I missed off a 0, I think. Times 100 is 37%. Well, that is well over 5%. So, is Danielle correct? No, she's clearly not. Okay. Had to double check there, but that's it. If you see something like that and you think, oh, that looks a bit odd, because our answers are very different, you just check it, you do it again. Or we could do some cancelling. We could cancel a 0 there with 1 there, another 1 there. So you end up with 370 divided by 10. Take the 0 off, so we can cancel another 0. You end up with 37%. Yes, if something looks odd, check it. Okay. And then we're told, Danielle collects data about the ages of people who attend her fitness classes. Okay, we've got this tally chart here. Complete the frequency column for Danielle. So she's made her tallies, but we've got to know what numbers these tallies represent. Oh, 1, 2, 3, 4. Now each of these groups is worth 5. So 5, 10, 11, 12. 5, 10, 15, and 1, 16. 5, 6, 7, 8. There we go. Question 7. Andrew sells cheese. He wants to put the cheese in a box. The box is in the shape of a triangular prism. Here is a sketch of the box. So we've got our drawing of the triangular prism here. Looks a bit like a tent or a Toblerone, something like that. Instead of the actual measurements, they've given us letters. So we've got X centimetres up the diagonal, Y centimetres for the base, W for the length or the depth, and V centimetres for the height. Okay, we're told here is a net of the box. So they've drawn this out nicely for us. And they're saying that each of these one little squares is equal to 1 centimetre. Okay. And the question is simply, work out the values of V, W, X and Y. Right, so what I'm going to do first of all is to put these letters onto this net here. And then I think I'll make it easier to see what's going on. So this W centimetres is the length of it. So it's going to be down here. So this will be our W. I'm just starting with that because I think that seems an easy one to spot. So that's W. And if we know each box is 1 centimetre, we've got 1, 2, 3, 4, 5, 6, 7, 8 centimetres. So W is 8 centimetres. Okay, then what's a nice one to do? Well, this base of the triangle here is Y centimetres. So where's the base of the triangle on here? well, it's this distance here. So this is y, and it's equal to 1, 2, 3, 4, 5, 6 centimetres. So we've done y, we've done w. Let's do v next. That's this vertical height. Well, it could be here or here. I'll mark it here on the diagram. So this is v, and it's 1, 2, 3, 4 centimetres. And so the only one we haven't done is this x, this diagonal here. So this is x. Well, we can't just count the squares on here because it's on the diagonal. We could count it where it was horizontal or vertical, but this isn't going to work as well. But we have got a scale. We know that one of these squares is equal to 1 centimetre. So we can measure it. Yeah. And we can say, well, if we measure it here, that looks like 2 centimetres to me. So I'm just going to put, well, I'm not going to put equals. I'm going to do a line 2 centimetres because that's what we've measured. Okay. Now, if we look at the 1 centimetre here, well, we actually get 0.4 millimetres. Okay, so this is equivalent, sorry, to 4 millimetres or 0.4 centimetres. Okay, so what we can do, let's convert this centimetres into millimetres so they're both the same. Well, we've got 10 millimetres in 1 centimetre, so 2 centimetres, we're going to double that to 20 millimetres. Okay, so if we know that the full X on our measurements or our drawing is 20 millimetres and one of these boxes is 4 millimetres, well, we're going to do 20 divided by 4. Grab our calculator. 20 divided by 4. And we get 5 boxes. Okay, which in this case, now we can say, well, one box is 1 centimetre. So it's going to be 5 centimetres. Okay, so a bit more confusing with the diagonal because we've got to do some measuring. But it still works out. Because it's all to scale, we can do that. Right, now all we need to do is put our values in here. So what did we have for V? We had V was 4 centimetres. W was this one here, 8 centimetres. X is this one we did on the diagonal, which was 5 centimetres. And Y was the base of the triangle, which we've got as 6 centimetres. Question 8. Sarah employs 24 people. 1/3 of these people work in the repairs department. The rest of the people work in the sales department. How many people work in the sales department? So 2 ways of doing this one. The first way, this might be the way most people would think of it to start with. We think, well, if 1/3 of people work in the repairs department, well, we want 1/3 of 24. Now, if you're using a simple calculator like I am, when you're working this out, it's much better to put the whole number first. So 24 times 1/3. Now, I'll show you what happens. If we do 24 times 1/3, or 1 divided by 3, we get 8. Now, if we did it the other way round, if we did 1/3, 1 divided by 3, times 24, you actually get 7.99999. That's because of the way that a simple calculator works it out. Now, you could simply round it up which is fine, to 8. But just to avoid having to do that rounding, if you're multiplying a whole number by a fraction, it makes sense with a simple calculator to put the whole number in first. If you're using a scientific calculator, you won't get this problem. Okay, so we've got 8 people are in repairs. The rest of the people are in sales. So in other words, that's 24 minus 8. So 24 minus 8 gives us 16 people in sales. So that's our answer. Now, I said there were 2 ways of doing this. The alternative is to say, well, if 1/3 work in repairs, well, the rest of them must be 2/3. So we want 2/3 of 24. So again, if we put the whole number in first, 24, and then times 2 divided by 3, we get 16, which is the same as that. So that's just an alternative method. Question 9. Here is a fair 8-sided spinner. So the fair bit means that you've got an equal chance of landing on all 8 sides. Laura spins the spinner once. Write down the probability that the spinner will land on a section that includes the letter E. Okay, so we want a probability. So they've shown us they want it as a fraction. So we can say, well, how many possibilities have we got altogether? Well, we can count them, but they've actually told us there's 8 sides. So there's 8 possible answers. We're only interested in the ones that include the letter E. Well, that's E itself, or east, but it also includes northeast and southeast. None of the others have got an E. So it's 1, 2, 3. So we've got 3/8. The second part. Here is a compass. What is the bearing if you walk in the direction southwest? Well, if we're taking bearings, we'll start in the middle of the compass. We always want to imagine that we're starting off facing north, and that's our sort of like 0 degrees. Now we want southwest, which is over here. So what we're after is this angle all the way round. Well, I've got a protractor here, but it will only do half a circle. I can't measure this whole angle. So we could maybe work out this angle and take it away from 360, which is a full circle, but I'm not going to do that. I'm going to say, well, let's imagine that this line continued down there. So this bit, this half a circle, is 180 degrees. Okay, that's just this section here. And then what we want is this extra bit here. So if I line up my protractor, put the crosshairs in the middle, get one line following this vertical line going down, and then we're starting on this line, so we want to start with a 0. So 10, 20, 30, 40, and the line we want is halfway between. In fact, it's pointing right at 45 degrees. So this bit is 45 degrees. So the total angle all the way around is going to be the 180 plus the 45. Which gives us 225 degrees. Okay. And we can put that down here. Question 10. Polly is designing a display board. The board needs to be in the shape of a kite, have one line of symmetry, be 120 centimetres wide, and be 80 centimetres tall. They've asked us to draw a suitable display board on the grid. And there's something very important at the bottom of the grid, which is the key. And it tells us that one square length on the grid, so in other words, one of these, represents 10 centimetres on the board. Okay, so let's go back to the question. Right, so we need something in the shape of a kite. Well, a kite, and for this, it's good to just do a sketch. You don't always need to use your ruler. So a kite, we're going to have a sort of triangle on top, and then we tend to have a pointy bit at the bottom, so that we have these two sides are the same length, and these two lines are the same length. So our line of symmetry runs straight down the middle. It might not look perfect on there, but this is just a sketch. Okay, so we know that our kite's going to look something like that. It's 120 centimetres wide, but we're told that each of these boxes on the grid, each one box is 10 centimetres. So if we want to know how many boxes we need, we're going to need to divide this by 10. And the same with the tool. So dividing by 10, you can use your calculator or just cancel those zeros. So 120 centimetres wide is going to be 12 boxes. And similarly for the height, for the tool, we'll cancel the zeros. And it's going to be 8 boxes tall. Okay, so let's start, I don't know, somewhere in the middle. We'll go up here and we'll say that's going to be the top of our kite. Now, the width is going to go across this way, the height this way. I'm going to do the height first because it's easier. I know it's going to be exactly 8 boxes below this point. So 1, 2, 3, 4, 5, 6, 7, 8. Down here. And then we're going to have 12 boxes across. Now, it's going to need to be symmetrical, which means it's the same distance on each side. Well, half of 12, 12 divided by 2, is 6. So if we take anywhere on our centre line, say here, and we go 1, 2, 3, 4, 5, 6 to the left, and then go back to the centre, 1, 2, 3, 4, 5, 6 to the right, we can then join up our points to get our kite. Okay, so it looks a little bit different to my sketch up here. Mine's narrower, but this is fine. It's just a fatter one, that's okay. And it has to be because it's got to fit these dimensions. Okay, so maybe when I was doing the sketch, I would have known it was going to be wider than tall, so I could have drawn it differently. But it was just to give me an idea of what my final picture was going to look like. Okay, now they haven't said exactly where these bits go, so these points could be a bit higher or a bit lower, it doesn't matter, so long as it's this overall shape. And what I'm going to do is just do a dotted line down the middle to show where my centre of my line of symmetry is. And that's all we're after. Okay, question 11. Natalie wants to buy a travel bag. She finds the following information about 2 travel bags. We've got hold-on bag with a capacity of 38.5 litres and costs £82.99. And mile bag, the internal measurements are 0.25 metres by 0.3 metres by 0.6 metres. And that costs £81.99. The mile bag is in the shape of a cuboid. All right, so let's think about that cuboid. So that's like a 3D rectangle. Something like that. Natalie wants to buy the travel bag with the bigger capacity. She knows that 1 litre equals 1,000 centimetres cubed. Which travel bag should Natalie buy? Show why you think this. Okay, so we got capacity here. So capacity is measured in litres. But capacity has a connection with volume. So whereas capacity is measured in litres, volume is measured in metres or metres cubed or centimetres cubed. But we have got this link here between litres and centimetres cubed. So first thing we can do is we want to get our units the same. Okay, we've got litres, we've got metres. So what I'm going to do to start with is say, well, if I know 1 litre is 1,000 centimetres, I'm going to multiply this by 1,000 to get my answer into centimetres cubed. So 38.5 times 1,000. I'll put it over here so you can see it better. And we've got 38,500 centimetres cubed. Okay, now the mile bag. Well, now that we've converted it, this is really sort of volume. Now we know that volume is the length times the width times the height. Okay, so we need to multiply these together. But these are in metres at the moment, and we want the volume to be in centimetres cubed. So it's much simpler to convert them to centimetres before we multiply them together. Well, I know that there are 100 centimetres in a metre. So to turn these into centimetres, we're going to have to multiply by 100. Multiply by 100, and the same with that one. Okay, so 0.25 times 100 gives us 25, and that's centimetres. 0.3 times 100 gives us 30 centimetres, and 0.6 times 100 gives us 60 centimetres. So for our volume, we multiply them together. Doesn't matter which order. So we can do 25 times 30 times 60. And we get 45,000 centimetres cubed. Now, Natalie wants to buy the travel bag with the bigger capacity. Well, 45,000 is bigger than 38,500. Which travel bag should Natalie buy? Mile bag. And we've just got one more part to this question over here. Use a reverse calculation to show a check of your answer. So when we're doing a reverse calculation, we start with our answer. Well, our answer really was the, what did we have? It was the 45,000, wasn't it? I think, let's double check. Yeah, 45,000. So, if we start with the 45,000, reverse calculation, so we want to do it backwards. Well, we did the, I can't remember again now. We did 25 times 30 times 60. So if we do it backwards, we'll divide by the 60 and then divide by the 30. So 45,000, divide it by the 60, divide it by the 30, and it should take us back to the original number, which was 25. Check done. So that's the end of the paper. Please like it if you liked it. Subscribe to my channel. Make sure your notifications are on to get updates as I add new videos. Give me any comments, any questions, and look forward to seeing you again soon. Thank you very much.